Hey guys, so in this video I wanted to go over the scavenger hunt that we did today. So this document has all of the answers and the problems in order. Now if you went random or you didn't start at the same point as this document does, just go in order. Go find this problem where it says next problem, and then your answer will match the previous answer, the next one I go over. So for our first problem, it says graph this function. So I'm going to go to my Desmos. I'm going to hit the functions key, and I'm going to go over to the MISC, and then I'm going to go down to log A. The reason why I hit log A versus log is because I have a different base than 10. If I had no base that showed on my paper, if that 3 was not there, then I just could push log. But there's not. There's a 3 there. So I have to put 3 in the base. And then X in the parentheses. So that gives me my graph. Now looking at my graph, I could have gone around and matched all of the graphs on all of the different answers, and it would have matched this graph. And then I move on. So the next problem is rewrite in exponential form. So I'm looking at the base of my log is going to be the base of my exponent. Then my exponent is whatever my log was equal to. So 3 equals whatever the value I took the log of. So 125. So that should have been your answer, which is the next previous answer. So then you should have gone to rewriting this in exponential form. So we're taking the base of our log, which is 16, raising it to the 1/2 power, and equaling whatever we were taking the log of. Now this one was a little bit tricky because you had to take care of this 1/2. So we actually had to take our 2 and put it on the outside of our cube, or our root symbol. So we would have 2 square root of 16 to the first power equals 4. Or you could even simplify it more and just do the square root of 16 equals 4. And that is the answer that I made the next problem, or the next sheet. So then we go to the next one, rewrite in log form. So this one we start with our base of our exponent, which is going to be the base of our log, taking the log of whatever it equals. And then we're setting it equal to whatever our exponent is. And there is our form of our exponential that was given. So that would be the next one. So then we're given a exponential to rewrite in log form. Have a base of an exponent becomes the base of our log. Taking the log of whatever the exponential is equal to, and setting it equal to the exponent. And then there's our answer. So the next one, we are asked what is the domain and range of the graph to the left. So in this one, it's just below it. So does our graph go to the left forever and ever and ever? No, it does not. It keeps on getting closer and closer to x is 0. So our smallest x value is 0. And now does the graph keep going to the right forever and ever and ever? Yes, it does. This line keeps going forever and ever and ever. So our domain is going to be 0 to positive infinity. Now our range. Our range, our graph is going to keep going down forever and ever and ever. So it's going to keep on going down to negative infinity. Then it's also going to keep on going up to positive infinity. Did I put negative? Yes. So as we go up, slowly, but surely, we're going to be going up to positive infinity. So our range is negative infinity to positive infinity. And that should be our answer for the next little sheet. So then we're asked another domain and range. So looking at this, so on my answer key, I did do this very quickly, and I believe that there is not one on the quiz tomorrow that is this specific, dealing with so many decimals. But this line, this graph, actually gets really close to negative 0.5. Negative 1 is technically over here. So our domain, our correct domain, should be negative 0.5 to positive infinity, because it keeps on going to the right forever. And our range should be negative infinity to positive infinity, because it keeps on going up forever and it also keeps on going down forever. Now, if you had put negative 1, that's fine, because as you can tell on my answer for my previous answer, I put negative 1 because I just looked at it very quickly. Okay. So next problem, what is the asymptote of this function? So this one I have to put into Desmos. So log, I'm going to exit out of what I've got, hit my keyboard. I'm going to go to functions, go to log A, base of 13. In parentheses, I had 169x. And now it already graphed it for me, but I can also put y, or equals y. So then here's my graph. I'm asked, what is my asymptote? It gets really close to x is 0, but it never crosses it. Really close to it, but never gets there. So our answer, again, when we're talking about asymptote, it's a line that it gets close to, not just a value. So we are looking for the answer x equals 0, not just 0. Next problem, what is the asymptote of this log? So we're going to put this log into Desmos. Exit out of our log. I've got negative function log A. My base was 3, and then I have x plus 5. 3, x plus 5. And then I can put equals y if I wanted to, but it doesn't change it. So then here is my graph. So my graph gets really close to x is negative 5, but never crosses it. So we're looking for the answer, x equals negative 5. Next one, we want to expand this. So we first want to take care of our 5 in the exponent. And yes, I'm going to make this really big, so hopefully I can fit this in one screen. So the 5 comes down in front. So I get 5 log base 8 of x to the 5th divided by y. Now I'm going to take care of my division. So I have 5 log base 8 of x to the 5th minus 5 log base 8 of y. Then I need to also take care of my extra exponent in there. So I'm going to bring it down in front by multiplying. So then I have 25 log base 8 of x minus 5 log base of 8 of y. And there is my answer. And then we move on. The previous answer is there. So we move on to expanding again. We first want to deal with the cube root. So this cube root, all of these have 1 understood in the power or in the exponents. So to change this into an exponent, we have log base 7 of x times y times z to the 1/3. Then we're going to separate, or we're going to take care of the exponent by putting it into the front. So 1/3 log base 7 of x times y times z. Then I'm going to take care of my multiplication. So I have 1/3 log base 7 of x plus 1/3 log base 7 of y plus 1/3 log base 7 of z. And there's my answer. So that would match my previous answer that is showing now. Then I go on to my last one, which is a condensing question. So my condensing is we have to kind of redo all of the expanding that has already done for us. So I want to move my 6 back into the exponent with my x, and I want to move my 5 back into the exponent with my y. I'm going to use the space over here. So I have log base 5 of x to the 6 plus log base 5 of y to the 5th. So then I have to take care of my addition. My addition came from multiplication, so I've got to reverse it by putting that multiplication together. So log base 5 of x to the 6 times y to the 5th. And there is my answer. Again, as you guys are studying for tomorrow's quiz, if you have any questions, email me and I will try to answer them as best as I can.